In this video, I will use FX Workbench to add PC controllers to a BACnet network that were configured and downloaded as a zoning system in an earlier video. In FX Workbench 5.2, we updated the standards library so that it included the zoning system. If you create a new JCI station in 5.2, those graphics will be part of the station. If you use an old station, you will need to manually drag those library graphics over to the new station. Also, in 5.2, we updated tuning policies. A station running in 5.2 automatically gets all these new tuning policies automatically added to it. Also, the appropriate points type automatically have the appropriate tuning policy applied to it. Now, the two we're most interested in here are the network input policy and the network input peer policy. All network inputs get the network input policy applied to it. That comes with a min write time of 1 minute, a max write time of 10 minutes, and write on start, up, and enabled all true. This will allow writes going to the network inputs continuously throughout the day. And on a network input peer policy, we have a 0 min write time, a 0 max write time, and write on start, up, and enabled are all false. Now, the network input peer policy are never applied to any, and you'll have to manually apply those. Now, temporarily, I'm going to go ahead and change the network input policy to 0 max write time and write on start, up, and enabled false. This will ensure that writes don't go out to my controllers that have peer-to-peer communications going as I add them to the network. Now I'm going to go to the BACnet device manager and discover the points, or discover the controllers. Now I set this system up to operate on network 1000. So I'm going to go ahead and discover the devices I have on my network 1000. So here are the controllers. I'll go ahead and add the 3 controllers for my zoning system. And as I do that, I'll take this time to change the names. All right, now that they're added, I'm going to come up and switch over to the JCI import manager. And then I'm going to go ahead and select each device and apply my library to it. The first one has a mixed air for the air handler. All right, so here's the mixed air CAF file that was loaded in the air handler. It points to a library file here for the mixed air single duct.xml, which points to 2 graphics. One for the full-size graphic, one for the handheld. And I'm going to use these graphics to create new graphics. So I want a new graphic and a new HX graphic for handheld. Now, as a default, clean graphic comes up. And what that means is if a point does not exist on the downloaded CAF file, it will go ahead and delete the object that it was attached to in the standard library graphic. Now, the last selection is to update action menus, and I'm going to choose false. If I choose true, I'll only have the override command available, and I want to use the set command. Now, as as we work, this is automatically adding proxy points and automatically creating the new graphic, along with trends and totalization and alarms if they were selected. All right, now I'm going to go ahead and add a second controller, and this is going to be one of the zone controllers with the proportional heat. And now last, I'll add the MAC address 6 device, which has no backup heat, only the heat from the AHU. Okay, now that they were added, I can go into the controller. And let's look at the controller. I'm going to look at the points list on the point extension manager. Now, something that was added in 5.2 is the ability to come up here to this icon, select it, and add the tuning policy that are applied to each proxy point to the point extension manager. Now, each zone has 3 points that are being set up to the AHU. So zone demand, here's the network input policy, and I want to switch that to network peer. Zone 2 demand, zone temp. Again, each zone you use will have to be updated. And the occupancy. Now I can go down to zone 1, view the point extension manager, add the tuning policy, and each zone has 2 peer-to-peer connections coming from the AHU. So I'll have to change system mode to the peer policy and summer-winter to the peer policy. Now I'll go to the second zone. Again, go to the point extension manager, add the tuning policy, and go ahead and change those same points. Okay, now that that's completed, I can go back to the network input policy and change it back to the original setting. Now this is not a necessary step, but I don't like to send the null commands or the write commands when peer-to-peer communication is already started. Now let's go ahead and look at the air handler. Here's the graphic that was created. You can see animation on the fan. You can see the 2-stage heat, the 2-stage cool that we selected is there. Here's the bypass damper. Here's the mixed air damper. Here's the mixed air temperature, the discharge temperature, and the outdoor air. Also, since there's 2 zones, we have zone temperature and zone demand for each controller added here. Now these again are peer-to-peer, so you can see that the peer-to-peer communications are already up and running. And since I didn't send any null commands by having the other tuning policy, nothing has changed. Next, let's go to zone 1. Here's zone 1 along with the new graphic. You can see that the proportional heat is added to this graphic. And then last, here's zone 2. This is just the standard damper controller with no reheat. Next, let's go look at the points list. So I'm going to look at the points list for each one of the zone controllers. And I'll look at the BACnet point manager. There are quite a number of proxy points added to the network that are intended to help tune the system. Let's take a look at some of them. First of all, there's a damper output, so you can see the position of the damper. And you also have a zone demand. Now the damper output runs on its own separate PID block. So it's running and increasing on an increase in demand and decreasing on a decrease in demand, and doing it time-based. Now the zone demand actually comes from a separate block, a separate module. Now this is not necessarily tied directly to the damper output, but they both have similar inputs. Now the damper output here is 36%, and yet the zone demand is 75%. And that's tied to the heating span degrees. If I want to, I can go ahead and adjust this and change the setting. And essentially what this is going to do is really change the authority for that zone in the heating. So now I've changed this from a 3 to a 5, and you can see up here that the zone demand dropped considerably at 5. So a zone demand, a heating span degrees of 5 will decrease the authority of the zone, and you can increase that up to 1. So if I want to set this as 1, this will be the highest authority that I have available, and it'll have a much more impact on the reset of the heating stages or the cooling stages. As you can see now, the zone demand goes up to minus 100. The zone demand is based between minus 100 for 100% heat and 100 for 100% cooling. Now some of the other settings we have available is the damper maximum position. So if we need to reduce the amount of air going to this space, maybe it's some of the other spaces are being starved, we can decrease the maximum position of the damper. I also have a minimum position available for cooling and heating. So we can also change the minimum amount of air going out to the space. If too much air is going out at 10%, we go ahead and set that to 5%. Now, one last set is a voting reset. So right now we have a voting reset set as true and a voting inactive time of 2 hours. And what does that mean? So if the zone is at 100% demand for 2 hours and this voting reset is false, it will take that zone out of the voting. So if I turn this to false, the voting inactive time comes to play, and if it's at 100% demand for heating for over 2 hours, it'll take that out of the calculation. Now we have the same settings for each zone, and we can go ahead and change the heating span and the cooling span and the voting time and the voting reset and the damper max position, the damper minimum position for each zone. Now next, let's go ahead and look at the air handling unit and view those different proxy points that are available. Now there are several proxy points on the AHU that could use some explanation. First is the aux schedule. So both the AHU and the zones have an aux schedule point. So you'll need to create a schedule in your supervisor and attach them to each one of the zones and the AHU. The AHU shuts when the AHU goes to unoccupied mode, it automatically turns off the fan until the night operation is initiated, which is set to have the fan operate at 60 degrees for heating and 85 degrees for cooling. Next, there is an app mode. The app mode comes set as auto. Now, as long as it's in auto, the AHU will automatically calculate what mode to be in. If you desire, you can go ahead and manually command it to cool only, heat only, or fan only. Again, in auto, this happens automatically, but if you want to create some control logic to override this to cool only in certain conditions, that is sure available. Next, there's a economizer switchover set point. There's an outdoor air damper minimum position. There's a cooling lockout and a heating lockout. Right now it's set for cooling to take place only when it's above 60 and heating to take place only when it's below 60. Next, there is a discharge air control select. Now this comes set as false, and when it's false, the stages come on by either the highest cooling command or the highest heating command. Stage 1 will come when the damper position or the zone demand is above 40%. And stage 2 is set to come on when it's above 60%. Both of these have a 25% differential set to them. Now in the heating side, we also created a bypass damper H2 disable position. So if the bypass damper is above 10% open, we actually disable stage 2. Now you can go ahead and adjust any of these points, but this was created so that if the bypass was open, there wasn't enough zones calling for heating, that we would go ahead and disable heating stage 2 so it didn't go off on high limit. There's also a minimum night fan on time, so if the night fan comes on, it'll stay on for a minimum of 300 seconds. And here's your unoccupied heating set point for the night fan, 60 degrees, and your unoccupied night cooling set point, 85 degrees. Now, if the discharge air control select is set to true, the controller goes from a zone demand controller to control the stages of heat or cool to a discharge air control. So we have discharge air cooling low, discharge air cooling high, discharge air heating low, and discharge air heating high. So you can go ahead and set these to your desired reset schedule, and now this controller will act as a reset controller. Now this has been a video explaining how to use the FX Supervisor with the PC zoning application.